Hello, welcome to the tutorial for the CERN root. In previous tutorials, we discussed how to write out trees to a root file, and we discussed several ways like use the single branch or use struct to write in a branch with several leaves and or uh, a, a class or object to write into the root file here. So this is naturally to discuss later how to read the setup from the root file here. So in this demo 3 that see here, I will talk about from very beginning how to read a tree. I mean, the read is means to retrieve the data, so you can get some variable you set out there, and you read the tree. The data will flow from the tree to your variable, and you can do any manipulation or operation you want. All right, so let's start from a very easy one. So we start from the example one, the root here. So we already create by in the demo one here. So we create is a very simple one. So you can see um, this just for three variable money A, money B, and money C here. This integer data type, and we link by each variable by each branch. Each branch has just one leaf here, and write out, and we call the branch name MA, MB, and C. Let's call the money A, money B, money C here. Alright, so and we save this tree into the into a root that is example one dot root here. So that's read in. So this line I'll tell you I create the T file object F, and I read in example one dot root, and I don't put any option like update or recreate. Here is simply just reading here. So we read in the file. Again, I usually type ls to see what inside here. So here in the memory we have a T tree object called T in our memory, and the title is a simple tree here. So we can access the tree directly already, like print. As I showed you before, there's a branch called MA, MB, MC here. But it is good to declare a tree pointer for the latter use, because maybe you will use the T file object to open another file. So now your memory will occupied by that root file. So the memory cannot have the same one. So your content in example one, that root would just gone because you use T file to open another guy. So it's good to set up a pointer to retrieve or reference to the tree you want to do in case you open another file later, like you want to make a gate. So you open the gate file, the file that saves the gate. So we have a pointer that say is point to a tree class, and it code T here. Here I name it T because the tree inside the example one dot root is also called T, so it would not cause any confusion which T I code. So I can use the f dot. This is the member, the sorry method called get object. So it will assign the the object code T inside the file F here, and it's pointed to the T we just create. Alright, so you have key will give you the name. Is a class point, this class for the T tree. So if you can do the same thing like T1 and you type T1 is 0 here. So if you do this thing by T1 and you type T1 again, now you point to the tree T here. Okay, so you get an idea. So these two lines just tell you I open a file, then set up a pointer that I can access the tree inside this file here. Alright, so generally you can have T1. Alright, you see the branch name is MA and the leaf name is money dash sorry underscore A and type is integer. So it's relatively easy to read in the branch or link the branch variable. So the logic is that we create the variable, then use the set branch address to link the variable to the branch. Then we use get entry that to retrieve the data from that entry, so we call it get entry, just like the inverse way to say that field method. Field means that to put the variable into the branch. The get entry is called the data from the branch to the variable. It's just inverse way of the field. Okay, so that's again. So we create some variable here. Generally, you can use the same variable. You just create like money A, money B, money C here to retrieve the data inside here. But here I just want you to understand the syntax. So I use a different variable name. So I called A, B, B, and C, C. That's for retrieving the data in MA branch, MB branch, MC branch. Alright? So we create the variable already. So now we link the variable to the branch. Alright, so we use set branch address. Alright, so the first parameter or argument, you use the branch name. If you don't know, you can type tab. You can see the branch name is the first one here. So the branch name I know is M. A, I want this capital A here. So this part is a little bit tricky here. Is a address of something. So okay, so now you see two asteroid. It means some address here, something. All right, it's a little bit complicated to explain, so I skip this part. All right, so because we need to link my address, so this is integer. So we have ampersand operator there to represent the address of that variable that is AA here. So ampersand AA. So enter. That means we link the AA, this variable we just created here, to the variable money the underscore A here. We use this method to link it. Alright, so we do the same thing for the rest of the two. I'll just copy and paste it. Alright, very good. So we link all the variable within the tree and the variable we create here. So the first thing we can do is to retrieve, just like the get entry. Okay, so before that, we see what happens if we use the cout to print the variable we just declared. There should be some weird thing or 0 because we don't use get entry. So if we use get entry here, right? So now there should be something. Yes, so this is a 10, 30, 60. Oh, this number because we just fill in a 10, 30, 60 here. So we can try one more. So we get entry indexed by 1 and to see what happened there. So you see this 20, 30, 50 because we fill the data by 20, 30, 50 here and use get entry. You can see that. So you get the idea. So you can operate like your variable AAVVCC with the data in the tree here. So another very interesting and useful thing is the get entries here. This tell you how many entries there. For example, in this tree, I just have 3 entries. So you can see this is 3 here. So it's very good information for looping because we need to know how many times we should run it. So you can use cout to print out. We code this get entries. It's a Perl and line. So you got 3. All right. So let's say we want to print from all the entries to see the AVVCC. What you can do is to type in a loop here. So basically is for loop integer, let's say um, I equal to 0, then I less than t get entries. Tell me right, okay. Then I plus do whatever you want, like this. Get entry, and it prints out. I think you understand what I'm saying. So for saving time, I just copy and paste. So you see this all the entries and the result here. 10, 30, 60 is just exactly what we see previously here. Alright, so you got the very basic idea how to use the tree and read it. So let me summarize it. So in order to retrieving the data, you open a root file, and if the root file inside it has a tree called T, is a good practice to create a tree pointer to let this tree can this pointer can reference the tree here. Then if you want to open another file, it will be saved here. So you observe the structure of the tree. In this case, it's a one branch, one variable. It means one branch just has one leaf. So you set every branch by the branch name and the address. Here you don't need to specify the type because the type of the data is specified here when you create. So if you know how you create the when you write out a tree here instead of branch, actually it's pretty easy. Just copy and you set branch address. That will be done here. And of course you need to set out money here. This is a very simple way. If you know how to set a branch, then it's very easy to set a branch address, just reverse way. Alright. Okay. So once you set out the branch and the variable properly, you should have linked it successfully. So you use the get entries, and the number that is means the which index, which entries you want to get. So if you get that, so you means that the data from the tree will flow into the A, B, B, C, and you can manipulate that one. And the method get entries would tell you the total number of entries in a tree, and you can do a looping. It's a very common practice for uh, getting a histogram or plus something or do some take an average something. So I think you get the idea. So I will stop here. Alright, let's go to the next example. Example 7 will tell you how to read in an array. Okay, so this will be very short one because reading an array and reading in a basic type variable like integer float would be very similar. The only difference is array is kind of like address. So when you set a set range address method, you don't need to have ampersand. This is the same as you write down. So let's step by step to demonstrate this example. Okay, so the first thing is again to read in the exist the root file here. So you see then I type ls. I think I see there is a tree called T here. So I create a pointer that is T called T, and I use the method inside the T file object. This get object, it will point this T tree to my new pointer here. Okay, so this is kind of routine. Alright, so then we observe the uh, tree structure here. So you can see here is this is a two. Sorry, this is a branch. Now the branch name is A here, and it have leaf. The name of leaf is bank from A here, and this bracket means this is array, and this will have a two element with it. So it's from index 0, 1, and this branch called B, and again it is an array, and it has three element with it. So you know how it's write out. The code is write out. You can take a look here. It's use the branch method. You code set out the branch A link to the A account. This is a variable. This is actually an array here. And the leaf name is set out bank from A, and this array with size of 2, and each one is integer data type here. Alright, so in order to retrieve it, we need to set up the exactly same thing here. So you just copy what you declare here. I just use this code again because it. Alright, so now I link the variable in the tree here to my array. Here again is a set branch address. This option, actually you have a lot of options, at least 3 options to link your variable to a branch. The set branch address would be the most recommended way. That's written in the manual, but there is some options I will talk about later. So far, you just follow the sec branch address, this method. This is most general useful, but some cases you need to use another method. Alright. So again, we already said the set branch address first parameter is you need to type in the branch name. So the branch name is A here. Let's just copy. And the second is the address of the variable you want to link. Here I would like link the branch A to my variable here. So I copy it and I paste it. Okay. So notice you don't need to specify anything in here. You just copy here to here. So you just need to know the address here. You don't need to know the type or the size. It's just fairly simple. Alright? Because when you declare the variable, it will tell you the size and the type here. So tap enter. I got it. Now another thing, another range again, copy and paste. Alright, so what I have to do is to get entries that say entry, first entry. Alright, so let's see what happened here. I use the C out to take a look. So it's 10 and 110 here because we fill the data by this. The first entry, the first entry is the index 0 here, the 10, 110 here. So do the same thing if we want to check the B account here. So it's 999, 999 here because this part is the first entry. Okay. So I think you got an idea. In this example, just tell you when you want to read an array, you don't need to specify the ampersand operator here, and you can observe the the tree structure by looking at this. If it's an array, you have the bracket here. All right, very good. So I think this will be the end of this example. Alright. Alright, so let's take a look at example 8 here. So in this example, we will discuss the taking an array or reading an array from a varying size. Okay. So again, let's read in the file here and retrieve the tree. Alright. So let's say TF. I already know I set up T and I print it. So let's observe the structure first. So this tree called T here, and it has 3 entries. Alright. So it has 2 branch. Branch 1 is called size. Branch 2 is called energy. The branch 1 is the leaf is M and the type is integer. And branch 2 here is called particle energy. With the bracket that means array, and each array is integer, but this is and here means it's a varying size according to the branch here. So for example, if the branch size with 1, this will be just a array with just 1 element. If 2, this will be an array of 2 elements here. I think you got an idea. So in order to retrieve that varying size array, you need to set up the array first exceed the maximum possible size. Otherwise, you cannot store that it. So in this case, I set up 100. That's just way enough. And n means the size here. I just use the same notation here. Alright. So I set up the variable, then I have to link it. So I use the set branch address. So first is the branch name is here, the size, and I link it to my variable n here, and I have to add ampersand because it's an integer data type. It's not array. So I copy, then I paste it, enter. Ooh, okay, because I forget this line. Don't worry. Alright. Then copy it. Alright, there is no complaint. Alright, so then I set up the energy array for this energy here and branch here, and I don't need to specify the type or the size, so I just do it. So next thing, I set up a shorthand notation called NN that will represent the total number of entries in this tree T here. So it's an integer, so I use the integer, the NN, to represent my number of the entries in that tree. Alright, so now I write a for loop. So in this for loop, there is an interesting line here. So this line tells me whenever I go inside this for loop from the index 0 up to the end here, the maximum number of the entries, I erase every entries in the energy array. That means I don't want the memory from previous ones. So then kind of initialization every time. Then I use the get entry I to kind of get or retrieve the data from the tree to my variable here, and I print out everything like n and energy with first element, second element, third element here. So let's see what happened there. So I copy this whole block here and type enter. So it's the, if you have 0 means that it is just no data. So first one is number 1 means I just got the size of array just 1. So the first is the array real number, and 0 is because I put some initialization condition here, so you see a 0. So this is 2, you have 2 number here, 3 number here. That's because we fill the data by this structure here. The first time we fill, we just had the 1. The second time we have 2. Third time we have 3. So you will see this structure here. So if you don't put this initialization, there will be funny thing happen. Let's see. So first thing, if I get entry with index 2, and let's see what happened. So you get 3, number of 3, so you have an array with size 3, 1, 2, 3 here. Now you go back to the array with the index 0. See what happened here. Now you see this 1, but you got some number here. That's because you don't put a initialization condition here, so you will get some funny thing here. So you have to keep in mind, when you're dealing with varying size, you need to have 2 variable. One is for the size, one is for the data in that array here. And remember, you need to be careful about the initialization to erase something like the different size of array, and that part doesn't change within the fillings process here. So I think you get the idea. I will stop here for the next part.